In this video, we'll talk about properties of relations. So suppose all of our elements come from just one set A, and we have a relation that's a subset of A cross A. So we're only going to be looking at pairs of things here, like AB, AA, AC, and so on. There's three different properties that describe how the elements are related to each other or to themselves. So the first thing is reflexivity. We say that a relation is reflexive if for every single element in our set A, we have the pair AA in our relation. So, for example, if we have three elements A, B, and C, it is reflexive if we have A and A in our relation, and we can represent this with dots. So we can have a circle, we can call that A, and we can draw arrows to see how things are related. So in this case, A is pointing to itself, so AA is in our relation. BB is in our relation because B is pointing to itself, and CC is in our relation, so C is pointing to itself. And because the only elements that we have in our set are A, B, and C, and each of those things is related to themselves, it is called a reflexive relation. Now, in syntax, you might remember reflexive from a sentence like, John likes himself. So himself is what's called a reflexive because it refers back to the subject in this case. So John and himself represent the same person. So in this sense, if we had a verb like likes, then we would have John in this relation because John likes himself. So that's where reflexivity comes from. So in order to check, we have to say, okay, for each of our elements in A, is that element related to itself? In other words, can we draw an arrow pointing to itself? We have another concept called symmetry. And basically what this says is that if A is related to B, we have to have B related to A. So if we have an arrow from A to B, then we should get a corresponding arrow from B to A back. Basically, this means that if we have, say, I don't know, the element CB in our relation, then we should have BC in our relation as well if it's symmetric. So you can think of this in terms of like siblings. Obviously, like let's say Mary and John are siblings of each other. Well, if Mary is a sibling of John, then clearly John is a sibling of Mary. That's a symmetric relation. Now, the last one is called transitivity. And basically, this one says is that if A is related to B and B is related to C, then we can take a shortcut and we can say that A is directly related to C. So you can think of this as something like younger than or older than in terms of age. So we know, for example, that a 9-year-old is younger than a 10-year-old. And we know, for example, that a 10-year-old is younger than an 11-year-old. So we say 9 is younger than 10, 10 is younger than 11. Therefore, if this is transitive, we should also have that 9 is younger than 11. So a direct relation from 9 to 11. So I went through these a little bit quickly, but the important part is that we get some practice with these and that we use verbs and use actual uh, relations in the real world to see if they're reflexive, symmetric, or transitive. But before that, there's one final relation that we need to talk about, which is called an equivalence relation. And this is sort of like the equal sign. And a relation is an equivalence relation if it is reflexive, transitive, and symmetric. Basically, that means is that everything is related to everything else. So if we have, say, just two elements, before we look at this big picture here, let's say we have A and say we have B. In order for it to be an equivalence relationship, we have to have A related to B related to A, and we have to have A related to itself and B related to itself. So basically, everything is connected to each other. So this would be something like is the same age. So for example, let's say C is 10, D is 10, A is 10, and B is 10 in this case. So 10 is the same age as 10 for each of these guys, so it's reflexive. Uh, if 10 is the same age as 10 and 10 is the same age as 10, then clearly 10 is the same age as 10. Okay, that's transitivity. And finally, if 10 is the same age as 10, then 10 is the same age as 10. That's symmetric. Now, it sounds ridiculous because I keep saying the same thing over and over again, and that's really the essence of the equivalence relation, is that they're essentially the same thing. They're all related to each other. So, those are just some definitions. I want to get into actual examples with verbs, their descriptions, and thinking about these. So, is a sister of. We're just going to imagine some situations here. Let's just imagine that we have two people. I'm going to call the first person Mary, and I'm going to call the second person John. Because it's linguistics and we only pick those two names ever, so why not? Let's do it. Okay, now imagine the reflexivity. Basically, we're asking for every element in our thing, uh, is that one particular thing a sister of itself? So can Mary be a sister to Mary? Can John be a sister to John? And the answer to this one is no, that's not the case. You cannot be a sister of yourself. A sister has to be some other person. So sistership cannot be reflexive. What about symmetric? Okay, let's imagine now that Mary is the sister of John. Is it necessary for John to be a sister of Mary? The answer to this one also is no, that's not the case, because John in this case would be a brother to Mary, not a sister. If you had two sisters, like Mary and Sue, and Mary was the sister of Sue, then yeah, Sue would be the sister of Mary. But because we can find one example where Mary is a sister of somebody, but that somebody is not a sister back to Mary, we know it's not symmetric. It's not symmetric in every case. Finally, the last one is transitivity. So we're going to have to draw three people for this. Let's use Mary, let's use Sue, and let's use John. So we're going to assume Mary is a sister of Sue, and we're going to assume Sue is a sister of John. Now, because those two things are true, is it necessary that Mary is a sister of John? And when we do this, let's think in terms of a family without anything weird going on. There's no remarriages, there's no incest or anything like that. It's just a standard, typical family that has, that's not even standard to not have divorces, but let's just pick a very simple family situation without any complications. Is it true then that Mary is a sister of John? And the answer to this one is yes, it is true. So if we have Mary being a sister of Sue, and if we have Sue being a sister of John, then we should be able to take that shortcut directly from M to J and say yes, then Mary is also a sister of John. So that is transitivity in motion. Next, let's try mother of. So let's first start thinking about one person for reflexivity. And we're going to pick Sue here. And we can ask ourselves, can Sue be a mother of herself? So can it be the case that Sue is a mother of herself? No, you cannot be your own mother, not without time travel. 2, symmetry. Okay, so let's say we have two people here, Sue and Mary, and let's suppose that Sue is the mother of Mary. Then, is it necessary that Mary is also the mother of Sue? And the answer to this one again is no, because if Sue is Mary's mother, then Mary can't also be Sue's mother. Again, we would need time travel to get that done, and there's a lot of implications there that we don't need to get through in this course, because it's slightly inappropriate. Anyway, the final example, transitivity. Let's say we have Mary, let's say we have Sue, and let's say we have Kate. Okay. We're given that Mary is the mother of Sue, we're given that Sue is the mother of Kate, so is it transitive? Is Mary then the mother of Kate? And the answer to this one also is no, because she would actually then be the grandmother. So the mother of the mother is the grandmother, not the mother directly. So the relation is a mother of is neither reflexive, symmetric, nor transitive. Okay, let's do the same age as, and actually we just did this one as an example on the previous slide. So let's say there's someone who's 10 years old. Is the 10-year-old the same age as himself? And the answer to this one is yes, because if you're 10, then yeah, you're the same age as yourself. what if there's two people? So let's say we have two people. This person's 10, and we know that this 10-year-old is the same age as this other person. So the other person must be 10. Then, is it necessary that the other 10-year-old is the same age as the first person? And the answer to this one is yes. Because if person 1 is the same age as person 2, then clearly person 2 is the same age as person 1. Okay, finally, transitivity. Let's take a look at this. I'm going to call this person 1, so P1, P2, P3. We'll do this one without numbers, just talk about people. Let's say person 1 is the same age as person 2, and person 2 is the same age as person 3. Is it necessary then that person 1 is the same age as person 3? And the answer to this one is yes, because suppose person 1 is 20 years old. Then because person 1 is the same age as person 2 is 20. Because person 2 is the same age as person 3, we know that person 3 is 20. Therefore, yeah, person 1 and person 3 are the same age. So is the same age as is reflexive, symmetric, and transitive. So we can also then call this an equivalence relation. And the key word that would give this away is actually the fact that is the same age as. So this same here is really giving that away, that we're looking at an equivalence relation. Okay, what about our last example, which is likes? So this is just a verb here. So let's imagine a situation where we have some person, John. Is it necessary that John likes himself? Is it necessary that John likes John? No, it's not necessary that John likes John. It is possible for someone to not like themselves. What if we have two people? I wanted to use John and Jack, but that's not good because they're the same letter. Let's use John and Ben. Suppose that John likes Ben. Is it necessary that Ben likes John back? The answer to this one is also no. So one person can like another, and that person doesn't have to like them back. So it's not necessarily symmetric. Let's do one more example here, and I'm going to add another person here, Fred. Let's say John likes Ben, and Ben likes Fred. Is it necessary that John then likes Fred? I mean, John likes Ben and Ben likes Fred, but does John have to like Fred? Again, the answer here is no, it's not necessary. So you don't have to like your friend's friend. I'm sure everyone has a friend of a friend that they're not too fond of. But that was reflexivity, symmetry, and transitivity in action. What I want to do now is I want to kind of look back at these definitions in a little bit more detail. So I'm going to cover all this because in the homework you will have to be able to read a definition and you'll have to determine whether a relation is that new definition or not. So R is reflexive if AA is an element of R for each A and A. So what this means is that for each element in our set, A, B, and C, we have to have that element related to itself. So that's what these arrows represent. The arrow is saying B is related to B, A is related to A. The symmetry relation is saying for every pair A, B, and R, so every time you have A pointing at B, you have to have B, A, and R. So you have to have B then pointing back to A. Finally, transitivity again says if you have a pair A, B, and R, so you have an arrow from A to B, and you have B going to C, then if it's transitive, you should have A going back to C. So again, we went over that at the beginning, but I'd like to reiterate it with the formal definition now that we've done some examples, just so you kind of can go through how you can read this, because you'll have to take a look at a new thing in the homework. So as always, if there's any questions, you can ask on the discussion board, or you can email me, and I will get to you as soon as I can.